classified as conductors and insulators. The materials which may be an atomic substance or molecular substance. Atomic substance, the fundamental subunit is atom. In molecular substance, the fundamental subunit is molecule. This is the pictorial representation of atomic substance and a molecular substance. In the solid material, the fundamental subunits are tightly bound. There is a close packing of the atoms or molecule. Close packing. No space. Space is almost minimized in the close packing of these subunits. The difference between the atomic substance and molecular substance is the nucleus. It is uninucleus, it is multinuclear. Atomic substance, one nucleus and its electron clouds. It is one nucleus and electron cloud. Nucleus, electron cloud. Nucleus, electron cloud. Its electrons. In molecular substance, we have more than one nuclei. That is 2 nuclei, 3 nuclei, 4 nuclei like this. And nuclei and its electron cloud. This is a molecule. Nuclei of the molecule and the electron cloud of the molecule. Electron cloud of the molecules. Likewise. This may be any number of nuclei. Depends on how many atoms combine to form molecule. That molecule formation because of chemical bond between the atoms. Chemical combination. In case of polymer substance, the nuclei number are in thousands or lakhs, and the electron cloud, because molecule is giant molecule. So this is what I am talking about this. The atom, every atom or a molecule is a combination of positive charge and negative charge. Nucleus contains protons and neutrons. Both of them are mass particles, whose mass is equal to 1 AMU. Mass of each proton or neutron is equal to 1 atomic mass unit. And proton carries positive charge, neutron carries no charge. The charge we are calling as unit charge, +1. And the electron carries negative charge. They remain as a cloud around the nucleus, electron cloud, because electrons may be in different orbits. That is, lower orbit, higher orbit, electron always revolving around, keep moving, cloud of electron. Electron carries negative charge, 1 unit charge, -1. So in all neutral molecules and atoms, number of protons is equal to number of electrons. Number of protons in the nucleus, number of protons in all the nuclei is equal to number of electrons, like this, neutral. Same number of electrons and protons in each fundamental substance. Usually the electron occupies a large space, voluminous. Nucleus occupies very small space. In this material, the compact material, that is in normal conditions, this is fixed. Nucleus is always fixed in the solid. This is nuclei together, all fixed. And this electron cloud, I am talking about the electron cloud, there are some electrons. In the same atom, same number of electrons. these electrons always confined to this atom, will never move from this atom to this atom. And electrons always confined to this atom. All the electrons confined to the respective atoms. All the electrons of these molecules, that is confined to their respective molecules under normal conditions. Now, if you apply a potential to this material like this, if you apply a potential like this, potential difference on this material, positive charge, applied potential, external potential. In some cases, not in all materials, in some materials, it happens like this. That here, the valence electrons of this atom are as a molecule like this. Valence electrons means outermost electrons in the outermost orbit, outer electrons. It may be one electron or many electrons. And sometimes the valence electrons of the atom or molecule may be one atom, two atoms or three atoms, three electrons, one electron, two electrons or three electrons like this. Those electrons are loosely bound, not tightly bound with the nucleus or nuclei. Those electrons under these conditions leave the parent atom and occupy the next adjacent atom like this. Okay, electron of this come over here, electron of this come over here. It becomes electron deficient. Positive charge, positive charge. So positive charge because of the proton, excess proton, excess proton. Here excess electron, electron. Because carries negative charge, negative charge. Under this condition, only valence electrons, I am talking about only one electron, in some cases maybe more electrons are migrate. Only valence electrons can jump from one atom to other atom towards this what is a positive potential. Keep on jumping like this. This is called as electron movement or what is that free movement of electron. There you see the material, electron freely moving from one point to other point, from this potential to this potential. This is jumping, hopping from one atom to other atom. And this here also, electrons are moving like this, only valence electrons. This migration create charges like what is that? Positive charges here in the opposite direction, positive charge, that is near this positive charges are created, near these negative charges are created. That is positive negative charges accounts for the electrical conduction. That is why it becomes a conductor. Only such materials. What materials? All metals are like that. Valence electrons, they are free to move from one point to other point in this direction of the potential. So it says that these valence electrons under this condition will not always confine to this parent atom. Next moment, this electron will behave like it confined to this atom as well, but excess. So here, because this atom behave like it is also confined to this atom. So all the valence electrons behave like confined to all the atoms of the material. They can migrate freely. So they jump from one atom to other atom, behave like they belong to all the atoms of the material. Overall, all these valence electrons behave like confined to the material as a whole. Only these electrons migrate. But positive charge nucleus, the protons will not migrate. So these electrons are moving. They are called as free charges, freely moving charges. Valence electrons. They are known as free charges. And this positive charge because of protons, nucleus fixed, never moving, but create what is that? Number of positive charges in the opposite direction. Is always bound. The protons which produces negative charge always bound with the nuclei, never come out of. fixed, it is called as bound charges. All the protons which cause these charges are bound charges, and electrons which we can cause these charges are called as free charges. This is about the meaning of the term what is the bound and free charges in a conductor. So it is there in some materials, this kind of material, what is that? A sea of electrons, free electrons, all the valence electrons can what is that? Migrate towards, behave like they belong to the material as a whole, not always confined to their parent atoms during the conduction. They are called as free charges, conductor. What is meant by insulator? The same material, what is a material like this? I am taking atomic substance, of course. You can take the molecular substance as well. When you apply the potential to this material, potential difference plus and minus, in this air, even in this condition, we don't see a cause like this. That is, all the electrons of the atoms, that is lower orbitals and even valence electrons, remain confined to this nucleus. But here, only valence electrons are migrate. The remaining electrons, the lower orbital electrons, will confine to the same atom. Not all the electrons move, only valence electrons move. But here, all the electrons of this atom always confine to this atom, the respective atoms only. They never come out of it. They do not migrate because those valence electrons are tightly bound with their respective nucleus. So in that case, what is that? This atom under this condition cannot behave like cannot create a charge like this. It is called as insulator. No electric current discharge. No electric current flow through this material. It is called as insulator. Reason here, free charges, even though electrons are there, free charges are not there. Bound charges, free charges and bound charges are not created with the application potential. Main reason is, even though valence electrons are tightly bound with their respective nucleus, these two materials is a nature's gift, because this conductor, as you know, the application of the conductor and insulator. This is the conductor, we are using electric conductor, where the electric power is generated in some place and it is transmitted to all over the places. Transmission by conductor. As you know, transmission by what is high tension line is away from the surface. That is away from the surface. There we don't require insulator. But when the conductors come near the surface for any applications here on, we need this insulator. All electrical wires are insulated because to avoid unwanted electric discharge, that is accidental touch by any living beings, whether plants, animals, what is that? So electric current pass, because all living beings, animals and plants, are very good electrical conductors. It's all because of there is so many electrolytes, presence of dissolved electrolytes in the body fluid or living being. These electrolytes, what is that? Inorganic ions, positive ions and negative ions, they carry electric charge, accounts for very good conduction. So any discharge of electricity or passing of electricity through what is a living being cause unwanted, that is cellular reaction or leads to death. That is why all electrical wires at the appliances, what is that, need to be insulated, only directing the conduction to the point of usage. That is why both are important. Conductor and insulator is a God gift. You know, this electricity is that you see in old field. It accounts for modernization developments. Without electricity, you can't have any developments at all. So every field the conduct electricity is the most important material. It's the most important, energy. This is about the conductor and insulator. Now coming to the behavior of insulator molecule of an insulator, atom of insulator. This is an atom of insulator, an atom or molecule of insulator. If you take that, what is that? That is a nucleus contains protons and electron cloud is here. So we know that here already we have polar molecules and non-polar molecules. It depends on what is that electron cloud and the positive charge separation like this. In this case, non-polar molecule or atom, you have number of protons, number of electrons, electron revolving cloud. But this electron cloud, overall cloud carries positive charge, net positive charge, some amount of negative charge. And all the protons of the nucleus carry, so many protons carry some amount of positive charge. The center of the positive charge, that is center point of all the positive charge together, center of positive charge, and the center of this negative charge, there is always centers, they are concentrating at one center, the center of negative charge. In case of what is that non-polar, coincided, the point of negative charge and the point of positive charge, net point, are getting coincided, that is negative and positive charge. Suppose this molecule or atom is applied electric potential. You know that electrons will not come out of the molecule or atom. When you apply electric potential, the same here, see that there is some distortion in this state. What is the electron cloud distortion? Here positive potential, negative potential. Here the center of, I am current here of this atom or molecule, the center of positive charge, center of negative charge. Here center of positive charge, center of negative charge are coincided at the nucleus. But here separated, nucleus is somewhere here, are separated. The center of positive charge of this atom and center of negative charges are getting separated because of distortion electric potential. It is called polarization. You see in the form of electron cloud distortion. Electron cloud, what is that? What is the shape is deviated, the shape is distorted, and the cloud, what is that, aligned more towards positive charge. Here electron cloud alignment is less towards the negative charge. This is called polarization of atoms or molecules in electric field. What is the amount of polarization? That is distance separation. It is by a simple mathematics, that is polarization, magnitude of polarization. What is the distance of separation? What is the magnitude of distortion, electric distortion? That is polarization is directly proportional to the applied electric field. That is electric field applied on this. Magnitude of the electric field, and P is the magnitude of polarization. Equals Z proportionally constant into E. Z is called as molecular polarizability. What is meant by molecular polarizability? Molecular atomic polarizability is how this atom or molecule is susceptible to electric polarization. Easy polarization or difficult polarization. That is called polarizability. So what is that? This signifies is that particular atom or molecule undergo more distortion or greater degree of polarization or lesser degree of polarization, because it depends on the molecular nature or atom. In some cases, in atoms or molecules, electron cloud is bigger, electron cloud is loosely bound, insulator. That is case, what is that? More electron cloud. If more electron cloud is more spacious, more voluminous, in that case it undergoes more polarization. The electron cloud is what is that? Less tightly bound, more polarization. That is called polarization, depends on what is that? Molecular nature, atomic nature. So it depends on the polarizability and electric potential, the magnitude of polarization. I'm talking about why this polarization. Look here, under this electric field, this is called as polarization. This molecule change to this. What causes, you see that observation? This applied field has direction, electric field direction. You know this electric field direction from positive to negative, direction of electric field. Direction of electric field. In presence of this external electric field, this undergo what is a charge separation. That is, negative charges and positive charges coincide. Charge separation. Here molecule, because of the charges arises. That is partial positive charge, partial negative charge. Because of these two charges, this molecule produces its own electric field. Of course, it induces electric field in the molecule. But electric field does induce, polarization does induce, this electric field is not in the same direction, it is in the opposite direction. This is the direction of the induced electric field. This is opposite. That is called as permittivity. So it permits its own electric field in between these two plates. So this electric field, right, after this polarization, this molecular behavior, this kind of polarization will find application. What application? It find application in the storage of electric power in a device like this. What is a device? Capacitor. Device is a capacitor. You know capacitor means that is two conductor plates of parallel plate conductors. Plates. And these are getting charged. Positive charges are accumulating by applying what is a battery potential. These plates are accumulated with negative charges. So with the increase of charges on this, as you know, the potential increases. The potential in this case increases. Or energy, potential energy or electric power is storing. Any accumulation of charges on this capacitor will increase the electric power, because we can using as the electric power generator, electric power as a battery of electric power. So now it has a capacity. What is capacity? Each one, what is capacity means accumulate the positive charge, number of charge. It cannot exceed that. So when it reaches the maximum capacity and produces what is that? Some amount of electric energy store up. That reaches a maximum. It depends on the what material used, depends on material of course. A suitable material can accommodate more charges. If that is the charge, what is that? If we take the vacuum like this, capacity like that. In between the plates, if we use a material, what is that? Fill the space with some material, or we take a solid thin material like this. Maybe a plastic, glass, a ceramic or metal, or insulator. A insulating material under the what is that? Is called what is a polarization or dielectric. This is called dielectric material. Undergo polarization means a dielectric substance. One which undergo polarization like this is called dielectric material. What happens by the opposite is positive charges are there, negative charges. Under what is a polarization? All the molecules what is that? Polarized. So negative charges and positive. Negative charges, all negative charges aligning towards this side. Positive charge towards the negative plate. This. Already what is the saturation is reached. Positive charge. These are full of positive charge. These are full of negative charge. And this causes what is that? This polarization causes what is negative charges here. Here not fully negative, positive charge. That is all toward this. This set of negative charges reduces the magnitude of positive charge. This set of negative alignment reduces the magnitude of negative charge, but you will not remove or reduce the number of positive charges accumulated or stick on the surface. Only magnitude of the positive charge reduced. So this reduction will make this plate to accommodate more number of positive charge and here more number of negative charge. If more positive charge accumulated and more negative charge accumulated, increases the potential or electric energy of this device. It is because of this electric dielectric material. So if the material has more dielectric, what is meant by more dielectric? More dielectric means here it is called dielectric constant. Permittivity, that is this material, it is permittivity with vacuum. It is same as capacitance with this material, capacitance in vacuum. More capacitance and here capacitance in vacuum. It is called dielectric constant. The material which undergoes more polarization, more dielectric constant, can what is that? Increase the capacity of the capacitance of the capacitor. This is capacitance of the capacitor. If that is the case, that increase the electric power storage in the material. That is application of dielectric material. We look for what is that? The material which has high dielectric constant. The solid, it may be a solid, liquid or gas. Solid like plastic. A thin sheet of plastic contains molecules behave like this. A thin sheet of glass contains glass molecules behave like this. A thin sheet of ceramics or mica have the molecules like this, behave like this. So these are very good dielectric materials. In addition to this, you can use water as a high dielectric constant. So here already what is that? A molecules in the non-polarity, a molecule already polar. Already what is that? Polarization because of what is that? Depends in the electronegativity of the molecule like this. This is about non-polar. So in case of polar molecules, already polarization occur when we subject to this external potential undergo further polarization. They orient themselves in this direction, undergo further polarization, that increase polarization further. Dielectric constant. So the material which has the highest dielectric constant is water. We can use water as a dielectric constant, but it has its own disadvantage. At some potential, that is beyond the potential, breakdown potential, this water becomes what is a conductor. So just because of that, we avoid water even though it has a high dielectric constant. Avoid this water as a dielectric material in the capacitor. We go for the material like this. This is one, or air, dry air also is as a, what is that? Dielectric material. That also increases the storage of the electric power. This is application of dielectric. Meaning of polarization, meaning of dielectrics. What is dielectric? Material whose molecules undergo polarization like this. More degree of polarization, more is the dielectric material, dielectric property of the materials. This is about the term polarization and dielectrics. So this is all about this. And let's come to the capacitor. Already I told in the last class, capacitor. In nature, we can see there are two types of lightning. Lightning between cloud and the earth. Lightning between the clouds. Just a phenomenon of capacitance. Capacitor. What is the cause for lightning? I will go a little bit deeper into this to make you understand. This is what is a rain clouds. Rain cloud is formation. As you know, the cloud of rain is formed because of super cooling of air in the upper atmosphere containing moisture. Super cooling of air containing moisture, very important. There should be some percentage of moisture. With that that is supercooling because of some convection current that is flowing low pressure, high pressure to low pressure like this. Make the particular amount of air undergo supercooling containing moisture forming a rain cloud. But what is the rain cloud? Supercooling means the water molecules in the gaseous state, that is freezes into liquid and also further freezes into ice. Ice means ice particles, magma particles. Because of supercooling, the water in the gaseous state suddenly becomes what is that solid ice particles. Very small particles, not bigger one, which can float in this, not come down immediately because smaller particles. And in this formation, we see that in the crystals, ice crystal beginning, and then what is that? Beginning, what is the ice crystal forming low density. After sometimes it becomes higher density. We see particles, ice particles of difference in density in this cloud formation. The ice particles which are less denser moving up in the same cloud, they are moving up, and ice which are more denser moving down. So these moving down particles, solid particles, moving up particles, what is that? Rub each other during this movement. It's all because of first ice particle formation. Ice particles of different densities. Higher density flow down, lower density flow up. So during this flowing down, up and down, crash each other, that is rubbing each other. The rubbing will exchange what is the charges. So the ice particles which are coming down gain electrons, and ice particles which are moving up losing electron. So upper portion of cloud acquires positive charge, lower portion of cloud acquires negative charge. In the rain cloud formation, it is because of supercooling. Look here, this is a negative charge facing towards Earth's surface. And always upper surface carries positive charge, abundance of positive charge. Now you see that layer of negative charge, layer of positive, it is exactly a capacitance. Behave like a capacitor. A plate of negative capacitor, a plate of positive capacitor. And the air is always trapped, that is, air is always present in between. This air is a very good insulator. If air is not there, electric current will flow. So air is present, is also called dielectric. This is an insulator. Never allow electric current to flow in this direction, this side. What happens if this, what is that, produces more charges to accumulate? This already charges are there. If there are more number of charges producers, and if the potential is reached, there is always what is here as some what is that breakdown potential. Until then, you will remain as an insulator. When the potential is reaching beyond the potential, losing the insulating property, becomes a conductor. If the charges accumulated in such a way, the potential difference goes beyond what is that breakdown potential, the air becomes what is that conductor. Electric current discharged through the air. Now electrons begins to flow towards the Earth. These electrons flow at high fast, that is faster rate. These electrons, that is ionization, cause ionization of H. Ionization contains molecules of what is that nitrogen, hydrogen, other molecules colliding with this electron. Knock out the electron. This electron can collide and knock out the outermost electron, becomes a molecule like nitrogen, hydrogen, like this, positive charge and electron. Okay. Ionization. This ions producing cause electric current. Electric current flow, that is negative electrons moving toward this, positive electrons moving this. That is the conduction, electric conduction. Electric discharge, lightning takes place. Electric current in this direction, electrons like this. So it is all because of this. And during electric led lighting, we can see light also. Why light? Because the light is what is that? This stream of electrons while moving towards Earth, colliding and knocking electrons, there is always electrons, some positive ions in the air combine with the electron, forming what is a neutral molecule or neutral atom like this. And this recombination, the electron combination, are not in the ground state. The atom is the excited state. The electron enter into the positive charge, will remain the excited orbital, not at the ground orbital. So this is the excited atom. It will attain the ground state by the electron jumping from the higher orbital to lower orbital, that emit light. The color of light depends on the height of jumping electron, making from higher to lower. You see blue light, sometimes white light, like this, very different light. So this light emission because of this physical process. During this discharge electric current, some electrons combine with positive charge, forming a neutral molecules or atom, and these atoms or molecules are in the excited state and coming back emit light. That is why light is seen during the lightning. In addition to light, why the sound, thunder we hear? It is because of in the path of the discharge, that is every bolt of lightning, what is that? You see that the path of this high potential difference and the electric current, high power of electric current is passing through, that produces heat, that is unbelievable amount of heat. The temperature rises to about 30,000 degrees centigrade along the path of the lightning. That path 30,000 degrees centigrade, and the air adjacent to that, it is rapidly heated. There is rapid heating, sudden heating or sudden, that is that sudden expansion. That heat allow that air surrounding or adjacent to the path, rapid expansion, sudden expansion. That sudden expansion of air, what is that? Produces sound. That is booming sound like that, or thunder sound. The sound that is called as lightning sound, thunder. The thunder is all because of heat liberated, and the light, it is because of this physical process. Both are simultaneously, but we see light early and sound late because of difference in velocity between the light and the sound. So this is the lightning between the rain clouds, the clouds and the earth surface. This lightning is dangerous for the living beings, because if they are caught in the path of this discharge, any living beings, the plants, animals, survived blood, they undergo what is that? They cause death, sudden death. That is lightning. Electric current pass through this. So it dangerous for this. And also this lightning causes some what is that? Fire, and also damaging properties. Because high electric current, if anything caught like this property or any living being, it will be getting damaged or death. That is the dangers on the surface of the earth. Here one more kind of lightning is there. What is the lightning between the clouds? The same phenomena. Here a layer of negative charge, a layer of positive charge. That is not shown. Another cloud below, a layer of positive charge and layer of negative charge. And this layer of negative charge behaves as one plate of capacitor. This layer of positive charge behaves as other plate of capacitor. If the charges are increasing, there is an insulator. If the charges develop beyond what is the breakdown potential, the electric current begins to flow through the air. Electric discharge, that is called as, it is the same phenomena. Both what is that? Sound and lights you can see between the clouds. But it's that lightning we see between the clouds. When you see from, just like it looks like from the horizon between the clouds. So lightning between the clouds. This kind of lightning is danger because it is not danger for anything on the earth. It is only danger for the aircrafts flying or caught in between these two. That is causing damage to aircraft or any flights. So these are the two kinds of lightning. So lightning is a phenomenon of capacitance and the breakdown potential and the insulator or dielectric. When it breaks the insulation, potential, beyond the potential, breakdown potential. So with this, we'll finish that the chapter electrostatics. Thank you all.